everybody please follow along. The very first thing to do is to label your coordinates, your equations, A, B, and C. I can't stress how important this is. A lot of students just want to jump right into it and start canceling things out, but it's very important that you label it A, B, and C. That way you could keep track of your work. So, if you take a look at step 1, it says to pick two equations and get a variable to cancel. So, out of x's, y's, and z's, what would you like to cancel? X's, y's, or z's? It doesn't even matter which one you pick. You guys want to cancel out y's or maybe x's? No. Z's. Okay, so you guys want to do z's? Let's cancel out z's then. And which two equations do you want to use? A and C? B and C? Okay, I want to use A and B. How's that? I want to use A and B. And if I want the z's to cancel, then I need this to be a positive 5z, so it'll cancel out with this negative 5z. Does that make sense? So what I want to do is I want to take the top equation A and multiply it by what? By negative 5. So what I'm going to write right here on the side is negative 5 times A, and I'm going to put a circle around it because that's going to be my notation of what I'm doing. Okay, so negative 5 times A is going to give me a new equation, and what's that new equation going to be? It's going to be negative 10x, it's going to be negative 5y, and it's going to be positive 5z, and it's also going to be equal to negative 25. Everybody with me? Okay, now we said we're going to use B also, and B, we're just going to rewrite it. So I'm going to write down B, and I'm just going to rewrite it. That's 3x, that's positive 4y, that's negative 5z, and it's equal to 0. Ladies and gentlemen, this is now ready to combine and cancel, and you guys wanted to cancel out the z's. That's why we manipulated both equations, or one equation, to cancel out the z's. My new equation will be negative 7x minus 1y, or just minus y, equals negative 25. Is everybody with me? So this is what I want to do. I'm going to box this in, and I want to call this new equation number 1. And that's what step 1 is all about. Picking two equations, getting a variable to cancel, producing a new two-variable equation. Instead of your x's, y's, and z's, we now have just the x and a y, no more z's, because you guys told me to cancel out z's. So now, if we read step 2, it says go back to your original, use the one equation you have not used yet. Which one have we not used yet? C. And if you keep reading number 2, it says get the same variable to cancel. So we're going to use z, which means this one, and I want the z's also to cancel. We canceled out z's over here, so I need the z to cancel out here. I need this positive 10 to disappear. So we're either going to use the top equation or the middle equation, either A or B, to manipulate it to cancel out with the positive 10z. So let's go with B. And how am I going to change B to cancel out the positive 10z down there? You're going to multiply B by what? By 2. That's right. So we're actually going to show this as the notation 2 times B, and I'm going to circle it. So it's very important that you label it so you keep track of what you're doing. And 2 times B will be 6x plus 8y minus 10z equals 0. And the one we have not used is what is really important that we use, which is a C value. And let me write that down. The C value is going to be negative 4x. We're not going to change anything. Minus 6y plus 10z equals 14. And now, ladies and gentlemen, we're able to combine the lines, and 6 minus 4 is 2x, 8 minus 6y is positive 2y, the 10z and the negative 10z cancel out, and we do have equal to 14 because 0 plus 14 is 14. Ladies and gentlemen, that was step 2, and we're going to call this new equation 2. So if we move on to step 3 says to create a new 2x2 system with your new equations. So it's a good idea to label everything, okay? So actually we should probably do that right now. Let's go and label this right here was step 1. All of this work right here. All of this work right here was step 2. Step 2. And now going for step 3. And that's creating a new 2x2 system. And that new 2x2 system comes from the new equations. So new equation 1 was negative 7x minus 1y equals negative 25. And the other one is positive 2x plus 2y equals 14. And ladies and gentlemen, we need to solve this new 2x2 system. Okay? That's what step 3 says. Create your new 2x2 system. Now we need to solve it. Okay? So this is going to take some work on to move this to the side a bit. I need to manipulate one or both equations. What do you guys want to cancel? Do you guys want to cancel out the x's or the y's? Y's? Okay, so what would I have to do? I'd have to multiply the top equation by what? By 2. So I want to put a times 2 back here and then draw an arrow to show that I'm multiplying everything by 2. So that's going to be a negative 14x. That's going to be a positive, actually no, a negative, let me erase that. A negative 2y. And equals, and if we multiply negative 25 times 2, we get negative 50. And the bottom equation, we're not going to change at all, right? So we're just going to rewrite it. 2x plus 2y equals 14. And now we're able to combine and cancel and solve. The y's cancel out. And you end up with a negative 12x equals, what is that, 36? Negative 36, thank you very much. That would have messed up everything if I would have forgotten that negative. So let's continue solving. That gives us a negative 12 that we're dividing by. And 36 divided by 12, a negative divided by a negative is a positive. X equals 3. Boom. But that's barely one answer, guys. Remember, we're solving the 2x2 system. So we have one answer to the 2x2 system. What are we going to do with this x value of 3? What are we going to do with it? Plug it in. Where am I going to plug it in? Into any of the 2x2 system, right? It wouldn't even make sense if I take that 3 and plug it in over here in the original. That's not going to help me because I still have 2 variables missing. But I have to, my only option is to plug it in into the 2x2, because if I plug in a 3 right here, then I'll be able to solve for y. So let's actually do that. Let's plug it into the bottom equation. 2x plus 2y equals 14. And you could have done the top if you want. Doesn't really matter. And I'm going to plug in that x value of 3. I took the 3 and I plugged it in right there. Okay. So I have 6 plus 2y equals 14. Let's solve this thing. You're going to subtract 6 on both sides. You're going to end up with 2y equals 8. Which means that y equals what? Y equals 4. I hope everybody's with me. You guys agree? Okay, so now for my final step, on this 3x3 system, I need to take my 2 answers that I have, which are the x equals 3 and y equals 4. What am I going to do with those 2 answers? Plug it in where? Any of the original. Because you have x, you have y, all you need is a z. Plug in your x and your y to find the z. So let me go to the original, which one looks like the easiest to do, A, B, or C? A looks easiest, okay? So I want to show my work up here. What was my x value? Do you guys have it? Here we go. A, it's going to be 2 parenthesis plus parenthesis minus z equals 5. And what was 3 again? I mean, what was x again? 3. What was y again? 4. So I really have 2 times 3, which is 6, plus 4 minus 2. That's not a 2, that's a z. Sorry, confusing myself with my nasty writing. That's a z. Equals 5. So I really have 10 minus z equals 5. So that means that negative z equals negative 5 if I subtract 10 on both sides, which means that z equals positive 5. Does that make sense? Yes. So how are we going to present our answer? It's no longer an ordered pair, it's an ordered triple. Okay, it's called an ordered triple. So the way to present it would be, again, in a coordinate format, but you don't have 2 numbers, you have 3 numbers, and they have to be in order. The first one has to be 3, the second one has to be 4, and the third one has to be 5. Now, I'm not talking numeric order, I'm talking about your x, y, z. Whatever x is has to go first, whatever y is goes second, whatever z is goes third. And that is the point in 3-dimensional space that these 3 different lines would cross at 3, 4, 5. That single point.